Hi everyone, this is Jake. Recently, TripoSR, jointly produced by TripoAI and Stability AI, has amazing results. The 3D reconstruction from a single image has also become a hot topic in the AI world. The models you see are first generated through the 3D reconstruction from a single image process and then adjusted. Let me talk about the conclusion first. The 3D reconstruction from a single image can be integrated into the 3D or game production process. Today I will introduce how to achieve it. This is the final baked texture. The tool used is the Texture Projector I created. My original plan was to try the image layering custom node in ComfyUI to directly generate a masked image, similar to the layer diffusion function in Forge. However, the test results were unsatisfactory. With the same parameters, this layer diffuse node will greatly change the original image, and the image quality will be poor. If you reduce the weight, the image will be close to the original one, but after the layers are split, the color layer will be overexposed and the mask will become pure white. It currently does not support image-to-image. So I gave up using it this time and looked forward to a better image layering node. If you have Forge installed, you can use its layer diffusion to generate. We are seeing Meshi, currently the most popular commercial solution for the 3D reconstruction from a single image. This is an image I generated using ComfyUI. The image-to-image and IP adapter processes were enabled. You can see the prompts in the subtitles. I have uploaded this image to Meshi and it generated a mesh model for me. The accuracy of the model and the uniformity of vertex distribution are quite good, but I don't know why its nose is crooked. When the material display mode is enabled, the result is not ideal. Although the resolution of this image is only 512, it is not so bad in theory. Maybe it's because the type of pictures chosen happens to be something Meshi is not good at. This result is difficult to use in projects. Not to mention Meshi charges a fee. I then tried TripoSR, currently the most popular solution for the 3D reconstruction from a single image. This result is acceptable, but the shape of the back of the head is not ideal. Click this button to download the model. But in terms of results, because the UVs of the model are automatically expanded and the texture resolution is low, it is hard to put it into use. Let's take a look at Wonder 3D. It first calculates the viewing angle in 6 directions, which is a great idea. The 6 directions include the front, left side, right side, left 45-degree viewing angle, right 45-degree viewing angle, and the back. But the head proportions are not good, and it doesn't understand the back of the head very well. The second set of images is the corresponding world coordinate normals calculated based on the 6 directional images. We keep this set of plans as a backup. After all, we have generated multi-angle images that can be used. I would run Wonder 3D locally and generate the model. Let's take a look at triplane Gaussian. This solution combines Gaussian splatting, but it doesn't quite understand the recognition of human faces. Unexpectedly, a mask was generated. Moreover, the operation method of the window interface is a bit strange, and it cannot be rotated to the front of the model. Let's watch the video. LGM also incorporates Gaussian splatting. The result is not bad, but a point cloud is generated. The model is transparent due to insufficient point cloud density from its edge. The PLY format is a point cloud file format. You need to use a tool it provides to convert the point cloud into a mesh model, similar to those provided by this page. I originally planned to try this solution as well, but because I didn't have enough VRAM, I gave up. However, because the algorithm is based on point clouds, there is basically no possibility of adjustment for the 3D production process. Finally, we focus on this CRM solution. This was proposed by the Chinese teams, including teams from Tsinghua University and Renmin University. Not only does this solution turn out great, the most important thing is that its process products, that is, the 6-direction extrapolation results, are great, and these images can be used in the later adjustment process. The difference from Wonder 3D is that CRM generates 6 positive direction maps: front, back, left, right, top, and bottom. There is also a set of world coordinate position maps instead of normal maps. CRM uses these 2 sets of images to generate the final model. This is the homepage of CRM, which introduces the algorithm logic. Images of 6 directions generated from a single picture, then the images of world space coordinates based on the 6 directions, and finally the textured model. Let me tell you my guess about the CRM algorithm. CRM provides the generation of Lego-style models, from which we can imagine that the algorithm behind it should be based on point clouds. Not a random point cloud, but a point cloud uniformly distributed by world coordinates. This is a lot like creating a Lego model in Houdini. First, a point cloud is generated within the volume of the pighead model, and then Lego cubes are generated based on the point cloud. Each cube reads the color of the model surface at the corresponding world position, which comes from the texture in the UV space. CRM first calculates the color information of 6 views from one image, which is very impressive. The model volume and point cloud are then deduced. Because the currently supported resolution of its large model is 256, there are 256 times 256 times 256 points, excluding points in the texture mask part, that is, points outside the model volume. Then, color sampling is performed based on the corresponding relationship between the world coordinates of each point and the 6-sided views to obtain the color information of this point. Finally, the volume point cloud is used to reversely generate a 3-dimensional model, and the point color is used to generate a UV space map. If you are interested, you can check out the video link of generating a Lego model by Houdini to learn more about the algorithm behind CRM. The CRM solution has been integrated into ComfyUI through this 3D Pack custom node. 3D Pack integrates all the solutions of 3D reconstruction from a single image I just introduced. I believe this will be another must-install custom node. Now let me introduce CRM in detail. What you see now is the interface of ComfyUI. Open the workflow for the 3D reconstruction from a single image. Before this workflow, an existing concept design or image generated through the text-to-image or image-to-image workflow should be prepared. Note that the image must be close to the front view of the subject. The reason will be introduced later. At the same time, the image background should be removed. The image alpha channel stores the subject mask to avoid misunderstandings by CRM and reduce computing power consumption. Several workflows are preset here. The first is to generate the MV. MV is multiview. Take a look at the multiview generated earlier. The consistency of the results is amazing. The only disadvantage is that the current large model only supports 256 resolution, which is slightly lower. You can see that each image is only 256 by 256, which is relatively small. Let's look at other cases. Now I use this headshot to create the CRM model. You can remove the background using the Select Subject tool in Photoshop. You can also directly use the Image Remove Background node in ComfyUI's custom node to remove the background, so you don't have to switch software back and forth. First, enable the multiview generation workflow and use the default parameters of the node. For large models, use this file prefixed with pixel. Click Run. The above node loads the image sequence and can directly read the process multiviews without generating them again. This random seed setting works perfectly for the bottom and back of the model. The multiview generation speed will be faster after the CRM model is read into the memory. I'll adjust the parameters and try again. If the multiview results are not ideal, you can change the random seed and generate it again. The head shape generated this time is better. I set the project name and the generated images will be automatically stored in the corresponding directory. I will choose this set of images to continue. Enables loading image sequences and turns off the multiview generation workflow. Notice the set of nodes here. Because the multiview format directly generated by CRM is a bit strange, an error will be reported when reading in the subsequent upscale workflow. The function of this group of nodes is to convert the image format to make it usable. The principle is to overlay each picture on a pure black background image and output. The picture remains unchanged, but the format is converted. Then generate CCM, which is a multiview canonical coordinate map or world coordinate map. Note that the large model here needs to be switched to CCM. The generation is complete. Something goes wrong with the bottom of the model, it feels hollow. The calculation behind the chin is very accurate. Adjust the parameters. It feels softer and the bottom of the model can be recognized. We can also repair multiviews, mainly adjusting the proportions of objects in the 6 views to ensure correct CCM multiviews. This will be introduced in the Viking treasure chest case later. Next, use 2 sets of multiview images to generate the CRM model. Enable the generation workflow. The model has been generated. The result is great, even better than the one on the official website. We still need to do one more step, upscale the multiview images. I enabled the method of upscale by model. Upscale the multiview images 4x to 1024 resolution. For the upscale model, I chose Kim 2091 Anime Sharp. The generated image will be saved in the upscale directory. The mesh model file just generated is stored in the mesh directory. A total of 5 pictures except the front view have been upscaled. How do I use these images? In addition, flaws in the images also need to be repaired. In addition to the CRM model, I will use the solution based on Wonder 3D combined with the NewS to generate another one. The NewS model has a higher number of faces than the CRM model. First, generate multiple views. Use the default parameters. After reading a large model, the generation is also fast. Multiview colors and normals were generated, and masks were generated using the background removal node. The results are the same as what we tested on the web page. Instead of using multiview images, we will look at the model it generates. Generating a NewS model takes a long time. The normal of the model is reversed. We can enable Flip Normal in the Switch Mesh Axis node to flip it, but I will do it in 3D Max later. Now you see a scene I created in 3D Max. There is a cube with a side length of 2 units, the standard size of the CRM model. 6 cameras are placed along the coordinate axis, facing the CRM model. The camera has orthographic projection mode enabled, with a viewing angle of 90 degrees. These 6 cameras represent the observation perspectives of the CRM multiview images. I imported the CRM model into the scene. It looks good. The first problem is that the texture lacks accuracy because the resolution of the sampled multiview images is only 256. In addition, the resolution of the baked image is only 1024. When you zoom in, you can see that it is blurry and the details are insufficient. Even if it is high resolution fixed to 2048, the details of the original image are difficult to reproduce. The second problem is that the model has a relatively high number of faces and is not built according to the topological structure of the human head. Although this model can be used, the result will be better after I adjust the model and texture. Let's take a look at the differences between the 3 models. They are CRM, TripoSR, and Wonder 3D plus NewS. When using the 3D Pack corresponding process to generate the models, but the latter 2 did not generate textures, maybe I made a mistake. First, Compare the number of faces. The CRM model has 40,000 faces, which is more appropriate. The TripoSR model has 160,000 faces, and the newest model has 1.07 million, much more than we need. Furthermore, the CRM model is closest to the reference image. The TripoSR model is quite different, and the proportion is wrong. The newest model has rotation and cannot be used. The front is somewhat similar to the reference picture, but the back is terrible. Through comparison, it is not difficult to conclude that the CRM model is better for this head. I applied a white material to the model and found many bumps on the surface. This is an accuracy problem caused by too low a resolution. However, the detailed features of the character in the reference are all shown. Then I optimize the model. I first take Pro Optimize, which comes with 3D Max, as an example, and I will compare several optimization methods in a moment. Control the number of faces of the model to 10% to 20% of the original number. Add the Relax modifier to reduce bumps and enable saving outer corners. Add an automatic smoothing modifier. Note that Pro Optimize will cause some faces to appear interspersed and need to be repaired manually. Finally, turn it into quad faces. What you see now is a comparison of several model optimization processes. This is the original CRM model. The models listed horizontally are the results of 4 optimizations based on the same model. Pro Optimize is the built-in modifier of 3D Max. Polycruncher and retopology are third-party modifiers. All major 3D production software have corresponding versions. ZBrush is also on the list. Retopology and ZBrush will retopologize the model, not just optimize it. The models listed vertically are reconstructed using different methods based on the CRM model. Subdivide is a built-in modifier of 3D Max that can evenly subdivide the CRM model. Voxel Remesher is a volume modeling method similar to Houdini's voxel mesh but without optimization. It is remodeled with a new, more uniform topology based on the volume of the CRM model. ZBrush Remesher is a model generated using the Z-Remesher tool in ZBrush to specify the face looping method and retopology according to the high number of faces. The CRM model is similar to volumetric modeling. You can recall its Lego model example. Comparing it with Voxel Remesher, it is not difficult to see the similarities. Of course, the Voxel Remesher model has a higher resolution. The Pro Optimize modifier is added to the CRM model, and the number of faces is controlled at 20% of the original value, from 40,000 to 8,000. The Quadrify modifier is added to turn it into quad faces. The Smooth modifier is added to create auto-smooth groups. Pro Optimize will adjust the face number distribution according to the changes in model curvature, reducing the number of faces in gentle places and increasing the number of faces in places with large changes. This is its advantage. However, when using Pro Optimize optimization, face interspersion will occur. This was discovered in previous testing. Polycruncher is very similar to Pro Optimize with the same modifier stack. There will be no face interspersion, and the vertices will be more evenly distributed. The Subdivide here chooses the adaptive method, which allows the vertices to be evenly distributed while subdividing. After subdivision and then optimization, compared to the model without subdivision, the vertex distribution is more even, and the number of face interspersions is reduced when using Pro Optimize. After Pro Optimize optimization, the number of model faces is adjusted according to the change in model curvature. The model optimized by Polycruncher will be smoother. Note that there is a problem with the Quadrify modifier of the model in the video. Many polygons appear and Quadrify modifier need to be added again. Comparing the models in the upper and lower rows, the model with subdivision will have better results. Check out the voxel remesher. Let's adjust the resolution value and see the results. The same modifier stack is still used here. Of course, it can also be optimized by reducing the resolution of voxel remesher, but details will be lost. In theory, this method will be better than the previous two rows, because using voxel remesher is equivalent to subdividing the volume of the CRM model. We can add more transition details. The solution for optimizing the ZBrush remesher model is not recommended. It is just listed for comparison. Because optimization will destroy the topology, then retopology loses its meaning. The retopology modifier combines the three functions of retopology, quadrilateralization, and automatic smoothing. I selected reform mode and set the number of sides to 8,000. It can be seen that the model topology is good, and there are loops, but it does not follow the structure of the human head. This ZBrush model is generated using the Z-Remesher tool to specify the face looping method and retopology according to a low polygon count. I will introduce it in detail in a moment. Let's compare them from the front view. My first choice is retopology because it is simple and effective. If you don't use third-party tools, then choose Subdivide with Pro Optimize. In today's video, I will use the ZBrush remesher of relatively low poly counts and the Subdivide model with Pro Optimize as examples to continue the adjustment work. Because I chose a human head model for demonstration, the best solution is to sculpt details in ZBrush and use Z-Remesher to retopologize and optimize. Import the model into ZBrush.
On a bright sunny day, the birds start to sing. As the gentle breeze blows, it dances on my skin. I feel the warmth of the sun filling up the air. It's like a symphony of nature everywhere. The sound of the waves crashing along the shore, the rustle of leaves as they fall to the floor, the rhythm of raindrops hitting the ground. It's a harmony of nature's music all around. The true harmony of nature's music all around.
You can add subdivisions and sculpt the model for more detail before drawing guidelines and retopologizing. Optimization of both models has been completed and their UVs have been recreated. Because it was just to demonstrate the subsequent baking process, the UV unfolding did not strictly follow the specifications of the human head model. I prefer this model using Subdivide with Pro Optimize. The face is tougher. Because I didn't sculpt, the ZBrush model looked too smooth. Export the model one by one. I'll make the final adjustments in UE. I now use the Texture Projector widget to make final adjustments. I won't explain it in detail here. If you are interested, please watch the detailed video. I will put the link in the description. How can it match the multi-view view angle of CRM? When you create a projection rig, it will be moved to the center of the bounding box of the selected model. Its position value needs to be reset to 0 to comply with the requirements of CRM. Make sure each projection camera is in orthographic mode and the ortho width is set to 200. This is because the scale of the CRM model is a 2-unit cube. In 3D Max and UE, the unit is centimeters. After the model is imported, it is upscaled 100 times and becomes a 200 centimeter cube. Rotate the top and bottom cameras based on the multi-view reference image. You can see that it matches perfectly. Check each channel. I mainly use outline images for alignment. Click Bake All Images. After creating the projection material, you can close the texture projector.
On a bright sunny day, the birds start to sing. As the gentle breeze blows, it dances on my skin. I feel the warmth of the sun filling up the air. It's like a symphony of nature everywhere. The sound of the waves crashing along the shore, the rustle of leaves as they fall to the floor, the rhythm of raindrops hitting the ground. It's a harmony of nature's music all around. The true harmony of nature's music all around.
Or you can first add details using the image-to-image method in ComfyUI and then make adjustments. The ears also need to be repaired based on the contour images. You can complete this adjustment step by choosing your familiar texture projection and baking tools. I fixed the flaws behind the ears. Import the textures back to UE. You can use 3D painting tools to repair the UV seams of the texture. Import the ZBrush model. Dark spots appear on the surface. This is because the model has changed and the depth texture needs to be updated. The projection rig position value must be reset to 0 before updating. In unlit mode, both models look identical. Subtle differences can only be seen under lighting conditions. Put the CRM, Pro Optimize, and ZBrush models together and compare. Next, I will use the Viking treasure chest as an example to explain why the reference image must be close to the frontal view and how to adjust the distortion problem.
On a bright sunny day, the birds start to sing. As the gentle breeze blows, it dances on my skin. I feel the warmth of the sun filling up the air. It's like a symphony of nature everywhere. The sound of the waves crashing along the shore, the rustle of leaves as they fall to the floor, the rhythm of raindrops hitting the ground. It's a harmony of nature's music all around. In true harmony of nature's music all around.
I plan to use ControlNet to control the perspective to ensure I only see the front of the treasure chest. But seeing more from the side will be better, which I only thought of later. On a bright sunny day, the birds start to sing. As the gentle breeze blows, it dances on my skin. I feel the warmth of the sun filling up the air. It's like a symphony of nature everywhere. The sound of the waves
crashing along the shore, the rustle of leaves as they fall to the floor, the rhythm of raindrops hitting the ground. It's a harmony of nature's music all around. The true harmony of nature's music all around. No need for words, the music speaks so clear, upbeat and refreshing, bringing cheer.
You can see that choosing a reference image close to the front view is very important for the 3D reconstruction from a single image workflow. Just as I edit this video, the Stability AI launches the SV3D model, which is more stable than Stable 0123, and the resolution reaches 576. If true, we have another locally deployable and practical 3D reconstruction from Multiview Images workflow. SV3D goes around the model and generates 21 pictures. However, the first and 21st pictures are the same, they are both the reference image. That is one image every 18 degrees. The consistency of multiviews is good, but the distortion problem still exists, which can only be weakened by making the reference image closer to the front view. These images in the directory were generated using the image of the warrior's head as a reference. After testing, when recording this video, ComfyUI only supports SV3D with an elevation angle of 0, and the number of frames is best kept at 21. If lower, the resulting results will be more distorted, and it seems that the algorithm behind it involves calculating the difference between the before and after images. The quality of multiview is higher when closer to the frontal view. The side view is not good. I also included the Stable 0123 process for comparison. Its viewing angle control is more flexible, but the resolution is only 256. It is generally only used as a reference for IP adapter, image-to-image, or image-to-video process. If they are to be used to generate models, high-definition restoration is also required. Stable 0123 has a poor understanding of the head structure. After ComfyUI support for SV3D is upgraded, Stable 0123 should be eliminated. There are several details to pay attention to in the workflow. First, SV3D or Stable 0123 requires the reference image to have a solid color background. So here's a process for adding a white background to an image with an alpha channel. Another advantage of adding a white background is that it will be more accurate when removing the background for the generated multiview. Masking is required for Gaussian splatting calculation, which can limit the calculation to the subject range without including the surrounding environment. Note that adding background and removing background is not a necessary pre-processing process. The mask can be pure white, indicating that all content needs to be reconstructed in 3D. This Generate Orbital Camera Poses node can quickly generate a pose list based on azimuth animation for each picture based on the number of frames of the input image. You can specify the frame range, orbit radius, elevation angle, start and end of the azimuth angle to the reference image sequence. However, it does not support camera pose lists for generating orbit radius and elevation animations. But I believe this node should be updated. SV3D currently only supports generation with an elevation angle of 0, so there is no need to animate it. Unfortunately, no orbit radius parameter is available. For Stable 0123, I used a stack orbital camera pose node, which can animate many parameters and directly export the camera pose list. The load image from batch node I used has a bug when reading the image masks. When reading all image masks, the first one will be missed. An additional node is needed to read the mask of the first image separately, and then merge with the masks of the remaining images. If the image sequence contains elevation animation, you cannot use this node to generate the camera poses list. You should make the list manually and convert it to the orbit camera pose data format. When using stable 0123, the generated multiviews are stored as an image list and should be converted into an image batch before they can be used. When using SV3D, the generated multiviews are stored in an image batch, but the number is limited to 20 and the 21st image is ignored. The frame range should be set to 0 to 19 in the Generate Orbit Camera Pose node. This 3D Pack custom node also provides another 3D reconstruction process. First, read the multiview and use the radiance field to generate point clouds and perform Gaussian splatting. Then use DMTet, which is deep marching tetrahedrons, to convert the Gaussian splatting results into a mesh model. In contrast, NERF or neural radiance fields takes time to render the results through the neural network. Finally, the multiview is resampled and the texture is baked onto the mesh model just generated. This is also the 3D reconstruction process officially recommended by Stability AI. But because I didn't have enough VRAM to run it, so I had to give up. One limitation of this 3D reconstruction from multi-image workflow is that you need to input the poses of the current camera, including orbit radius, elevation angle, and azimuth angle. Therefore, this process is more suitable for multi-view images generated by AI, because these data are set when the images are generated. If you want to try to use the captured footage, you need to find a way to get the camera poses of each shooting location. Either by utilizing a camera array, the poses of each camera are trackable, or use video to estimate the camera's motion structure, SFM. However, this becomes the camera tracking process in traditional 3D production and requires third-party tools. Currently, I have not found any custom nodes with this function for ComfyUI. However, I think someone will complete it soon because the CalMap SFM algorithm is open source. But there is little need to do this. After all, this is a very mature tool and process, and the effect will be better than that achieved in ComfyUI. And this is not our original intention of using ComfyUI for local deployment. What's more, from now on, we already have the 3D reconstruction from a single image workflow based on CRM plus ComfyUI plus UE plus Texture Projector. In addition, if you are interested, you can visit the SV3D homepage. It was compared with 3 other models and it produced the best results. An example of 3D reconstruction is also included here. You can open the video to see the process. Many commercial applications for 3D reconstruction have adopted the Gaussian splatting method, such as Polycam, Luma AI, and Reality Capture. 3D Presso is also one of them. I want to know if running the 3D reconstruction from multi-image locally can achieve this effect. If you are interested in 3D reconstruction, check out the links in the description to compare photogrammetry, neural radiance fields, and Gaussian splatting. Thank you all for watching.